Welcome to the Deep Dive. Today we're tackling a topic that's really reshaping things at an incredible speed: deep learning.
It really is moving fast.
We've got this fantastic report here laying out all the latest developments, the newest applications.
Yeah, it's pretty comprehensive.
So our mission today is to, cut through the noise, pull out the key insights, and really help you understand what's happening in deep learning, say between 2023 and 2025, and maybe what's coming next.
Sounds good. It's amazing how quickly this whole landscape is just shifting.
Totally.
This deep dive should give you a clearer picture of those key moves and how they're already changing industries. We'll definitely touch on the future, too.
Okay, let's unpack this then. Where do we start? The report seems to really emphasize the rise of generative AI and large models. That feels like the big one right now.
Oh, absolutely. That's arguably the dominant trend. And within that, you've got large language models, LLMs. Think things like OpenAI's GPT series, like GPT-4, or Google's Gemini. They've completely revolutionized natural language processing, NLP. I mean, it's not just an improvement, it's a step change.
In what way? What can they do now that's so different?
Well, they're enabling really advanced stuff. Text generation that sounds incredibly human, summarizing huge documents, translation, even generating computer code, and complex reasoning, too.
So what does that actually mean for, everyday applications or businesses?
Their ability to grasp and churn out human-like text has led to them popping up everywhere. Chatbots, obviously, but also content creation tools, much smarter customer support. Even things like legal services are using them now. It really raises a question, doesn't it? How deeply are these LLMs getting woven into just our daily digital lives?
And it's not limited to text, is it? The report also flags things like Jan's generative adversarial networks and diffusion models.
Correct. Yeah, moving beyond language. These models are fantastic at creating realistic synthetic data, especially images and video.
Synthetic data, like fake images.
Well, yes, but not necessarily in a deceptive way. They can generate, say, incredibly realistic human faces of people who don't exist, or create brand new artistic images. But also, crucially, they can generate data to train other deep learning models. That's a huge application, making training more efficient.
Okay, but while we're on these huge models, the report mentions something interesting. A shift from LLMs to SLMs, small language models. That sounds like going backwards.
Yeah, it might seem that way, but it's actually a really crucial practical trend. Look, these huge models are amazing, but they need enormous amounts of computing power, right?
Right. Very expensive, energy hungry.
Exactly. So there's this growing movement towards smaller, much more efficient models, SLMs.
Why? What's the advantage?
They need less computational grunt, so they're cheaper to run. They're suitable for running on, like, edge devices, your phone, IoT sensors, that kind of thing.
Okay. So not everything needs the giant brain in the cloud.
Precisely. And often, these smaller models can be easier to interpret, to understand how they're making decisions. It's about efficiency, accessibility, and sometimes transparency, too.
Got it. Okay. Moving beyond just one type of data, the report brings up multimodal AI. What's that involve?
So if we connect this to the bigger picture, multimodal AI is about models that can handle and integrate information from multiple sources at once, multiple modalities, like text, images, audio, maybe sensor data from a car. It's about understanding the world more holistically.
Can you give an example?
Sure. Think about autonomous vehicles. They need to process camera images, radar signals, maybe LiDAR point clouds, map data, and fuse all that together to navigate safely. That's multimodal AI in action. It allows for much more sophisticated, context-aware application.
Right, makes sense. The next one sounds pretty fundamental. Self-supervised learning, SSL. How's this a game changer?
Oh, it really is. This technique lets models learn from data that hasn't been labeled by humans.
How does that even work?
It's clever. The model essentially creates its own labels or tasks. For example, it might learn by predicting a missing part of an image, or figuring out if two slightly altered sentences mean the same thing.
Okay.
Given how much unlabeled data exists in the world, I mean, think of all the text and images online and how expensive and time-consuming it is to label data manually. SSL is massive.
So it unlocks all that unlabeled data for training.
Exactly. It's hugely important, especially in computer vision for things like object recognition and also in NLP.
Now, as these systems get more powerful and, frankly, more complex, the report highlights explainable AI, or XAI. Why the push for transparency now?
Well, this raises a really important point. As deep learning gets deployed in critical areas, think healthcare diagnoses, loan applications, and finance, we absolutely need to understand how they're reaching their conclusions.
The black box problem.
Precisely. We can't just trust a decision if we have no idea why it was made. XAI techniques are about shedding light on that process, providing insights, helping identify potential biases.
Building trust, essentially.
Yes, building trust and ensuring fairness. It's about knowing the why, not just accepting the what.
Another big challenge seems to be just the sheer energy these things consume. The report mentions energy-efficient AI and neuromorphic computing.
Yeah, that's a huge concern. The carbon footprint of training some of these massive models is, well, it's significant. So research is focusing hard on efficiency.
Yeah.
Two main angles, really. First, model optimization. Techniques like pruning.
Pruning, like gardening.
Sort of. It means removing redundant connections within the neural network, making it leaner. And quantization, which reduces the precision of the numbers the model uses. Less precision, less energy.
Okay. And the other angle?
Neuromorphic computing. This is more radical. It's about designing computer chips that are fundamentally structured more like the human brain.
Wow.
The promise is much, much more energy efficient and potentially faster computations specifically tailored for AI tasks. It's still emerging, but very exciting.
Interesting. The report also talks about transfer learning and few-shot, zero-shot learning. These sound like ways to make AI smarter, faster.
They really are powerful shortcuts in a way. Transfer learning is basically about not starting from scratch every time.
Reusing knowledge.
Exactly. You take a model that's already been trained on a huge amount of general data, say, identifying objects in millions of images, and then you fine-tune it for a specific related task, maybe identifying specific types of birds.
So you don't need millions of bird pictures.
Right. It massively reduces the data you need for the new task and speeds up development. Super valuable when data is scarce, like for rare diseases.
And few-shot or zero-shot?
But that's taking it even further. Few-shot learning means the model can learn a new task from just a tiny number of examples, maybe just 5 or 10.
Seriously?
Yeah. And zero-shot learning is even wilder. The model can potentially perform a task it's never explicitly seen examples of before, just based on understanding the concepts involved. It's more like how humans generalize.
That's incredible. Okay, another one here. Federated learning. Sounds relevant with all the talk about privacy.
It's absolutely key for privacy. What's fascinating here is that it allows models to be trained across multiple decentralized data sets, like data on individual phones or in different hospitals, without the raw data ever leaving its original location.
So the data stays put, but the model learns from it.
Precisely. The learning updates, not the data itself, are shared and aggregated. This is crucial for sensitive stuff, like healthcare data, where privacy regulations are strict.
Makes sense. Finally, under trends, deep reinforcement learning, DRL. What's happening there?
So DRL combines deep learning's pattern recognition power with reinforcement learning's trial and error approach to decision making.
Like AlphaGo playing Go.
Exactly like AlphaGo. That was a landmark moment. It's led to big breakthroughs in complex tasks, robotics learning to walk or manipulate objects, self-driving cars making navigation choices, game playing.
Are there still challenges?
Oh, definitely. Making DRL stable, efficient, and sample efficient, meaning it learns quickly without needing excessive trial and error, those are ongoing research areas. But the potential for real-world problem solving is huge.
And very briefly, hybrid models.
Yeah, just the idea that often the best approach isn't just one technique. Researchers are increasingly combining deep learning with other machine learning methods or even older symbolic AI approaches to get the best of all worlds. More robust, more powerful models.
Wow, okay. That's a lot of ground covered on the trends themselves. So we've talked about how deep learning is evolving. Now, where are we actually seeing these technologies applied today? The report lists, well, pretty much every sector.
It really is pervasive now. If we connect this to the bigger picture, deep learning is genuinely transforming industries.
Let's start with healthcare. What are some concrete examples?
Okay, healthcare. We're seeing faster, more accurate analysis of medical images like X-rays, MRIs helping doctors spot diseases like cancer or other conditions much earlier.
That's huge.
Definitely. Also, in drug discovery, using AI to predict how effective a potential drug might be, or how it might bind to a target molecule. It massively speeds up that initial research phase.
Anything else in healthcare?
Oh yeah, personalized medicine tailoring treatment plans based on a specific patient's genetic data, lifestyle, medical history, and even AI-driven training simulators for surgeons or doctors, letting them practice complex procedures safely.
Okay, how about finance? Seems like a natural fit.
Absolutely. Fraud detection is a big one. Deep learning models are incredibly good at spotting subtle, anomalous patterns in transactions that humans might miss.
Catching the bad guys faster.
Exactly. Also, algorithmic trading using AI to analyze market data in real time and make investment decisions, and sophisticated risk management, predicting potential financial losses more accurately.
Computer vision seems obvious, we touched on it, but what are the key applications now?
Right, it's everywhere. Object detection and recognition are crucial in manufacturing for quality control, spotting defects. In security, things like facial recognition or even detecting weapons. And of course, autonomous vehicles rely heavily on it to see the world.
What else in vision?
Image classification, automatically sorting images. Image segmentation, understanding what's what within an image. And video analysis, think content moderation on social media, analyzing sports games, surveillance footage.
And NLP and vocal AI, we mentioned chatbots and assistants.
Yes, and they're getting so much better, right? More natural conversations, sometimes even showing empathy. Think Google Assistant, Siri, Alexa, ChatGPT.
Yeah, the progress is noticeable.
Beyond assistance, it's automated text generation for reports or articles, summarization, sentiment analysis, understanding opinions online, and, of course, much better language translation.
Autonomous systems, cars,
Yep.
drones.
Yep. Self-driving cars are probably the most visible example, using deep learning to process all that sensor data cameras, LiDAR for navigation and decision-making.
But it's not just cars.
No. Drones use it for autonomous flight, inspection tasks, deliveries, and robotics in general, enabling robots in factories or warehouses to learn complex tasks and adapt to changing environments without explicit reprogramming for every situation.
The report then lists some areas that maybe aren't the first things people think of, like agriculture.
That's right. It's fascinating. Deep learning is powering precision agriculture.
What does that mean?
Using AI, often with drones or sensors, to monitor crops very precisely, detecting pests or diseases early, forecasting yields, optimizing how much water or fertilizer is needed in specific spots.
So more efficient farming.
Exactly. More efficient, more sustainable, also detecting wildlife that might damage crops. Then there's CRM, customer relationship management.
How does AI help there?
By analyzing customer data interactions, purchase history to predict things like which leads are most likely to convert or which customers might need support soon, personalizing interactions at scale,
And supply chains.
optimizing logistics, things like predicting demand, managing warehouse inventory more efficiently, tracking goods in transit, making the whole process smoother and less wasteful.
Cybersecurity feels critical.
Absolutely essential. Using deep learning for real-time anomaly detection, spotting unusual network activity that might indicate an attack. It's a key defense against increasingly sophisticated threats.
Energy and climate change, too.
Yes. Optimizing energy grids, balancing supply and demand more effectively, improving the efficiency of renewable energy sources, and enhancing climate models to get better predictions about environmental changes.
Okay, just a few more sectors mentioned. Retail, manufacturing, education. Quick hits.
Sure. Retail, demand forecasting, personalized recommendations you might also like, optimizing inventory, manufacturing, quality control, predicting when machines might need maintenance before they break down, robotic automation,
And education.
personalized learning platforms that adapt to each student's pace and style, AI tutors, analyzing educational data to help teachers and policymakers understand what's working and what's not.
Phew, okay. So deep learning is clearly everywhere now. Let's look ahead. What's next for the research and development side? The report talks about addressing limitations.
Right. The focus shifts now to making these systems even better, more reliable, and, well, more intelligent. It raises the question, how do we push the boundaries responsibly?
First up is robustness and generalization. Sounds important.
It really is. This is about making models less brittle. We want them to be less susceptible to adversarial attacks, tiny malicious changes to input data that can fool them.
Like tricking a self-driving car's vision.
Exactly that kind of thing. And generalization means making sure models work well on new, unseen data and in diverse, unpredictable environments. Not just the specific data they were trained on, reliability in the real world.
That reduced data dependency. We touched on this with SSL and few-shot learning.
Yes, it's a continuation of that trend, pushing even further to reduce the need for those massive labeled datasets, making AI development more efficient, faster, and possible even when data is scarce. More versatility.
And a continued emphasis on enhanced interpretability and ethical AI.
Absolutely critical. More research into XAI, making models more transparent and understandable, addressing fairness, bias, accountability, Building trust remains paramount as these systems become more integrated into society.
What about the energy problem? Increased energy efficiency and sustainable AI.
Still a major focus. Ongoing work on more efficient algorithms, specialized hardware like those neuromorphic chips we mentioned, reducing the environmental footprint and the cost of running AI is essential for widespread, sustainable adoption.
This next one sounds like a huge leap. Cognitive AI and reasoning.
Yeah, this is really ambitious. What's fascinating here is the goal to move beyond just pattern matching, however sophisticated.
Towards actual thinking.
Sort of, enabling models to perform more abstract reasoning, genuine problem solving, common sense understanding, maybe even continuous learning over time, more like human cognition. This might involve integrating deep learning with other AI approaches like symbolic reasoning.
Wow, okay. And real-time processing and edge AI.
This is about speed and location, getting deep learning models to run faster and closer to where the data is generated on the device itself at the edge.
We mentioned phones and sensors.
Right. With the explosion of IoT devices generating constant data streams, processing locally reduces latency the delay and bandwidth needs. It enables quicker responses for things like autonomous systems or real-time monitoring.
Finally, complex systems modeling.
This is applying deep learning's power to understand really intricate systems. Think modeling the human brain in neuroscience, or the complex interactions driving climate change, or even modeling social dynamics, using AI to tackle problems with massive complexity.
Okay, we've covered an incredible amount of ground, from the core trends like generative AI and maybe counterintuitively, the rise of smaller models,
Yeah, efficiency becoming key.
to its impact everywhere, healthcare, finance, agriculture, you name it. And looking ahead to AI that's hopefully more robust, ethical, and maybe even starts to reason.
It's really clear, isn't it? Deep learning isn't just some hot tech trend anymore. It's foundational. It's driving intelligent automation, providing real-time insights, changing how businesses operate and how we live.
It feels like a constant push towards AI that's more efficient, more ethical, more capable, and just more integrated.
Definitely. More integrated into our daily lives and our core business functions.
So, wrapping this up, what's the final thought for you, our listener? As deep learning gets woven ever deeper into everything from your health outcomes to the food supply chain, maybe consider this. How might really understanding how these systems learn and decide things, even just a little bit better, actually empower your own choices? And thinking about that, what new possibilities or maybe even responsibilities does that knowledge unlock for you in this rapidly evolving AI-shaped world?